Greetings and welcome, friends. Mr. Waddy here and my fellow algebruddies. We were graphing lines using Intercepts method on Friday. I was going to say yesterday, but that would have been in inaccuracy. And actually, even the people who see this video years from now could have seen what date it was posted on and then assumed that it was yeah, they would have figured it out. They're a clever bunch. They're a clever bunch. It's a Monday. Assuming Mondays still exist in the future and that we as a society have not voted them out of existence due to their offensive nature. So here we go. Here's it's asking us to graph the linear equation, and it just says x equals 4. Now, the weird thing about this is x equals 4 is not going to be graphed on a number line, which you might suspect. This is going to be a two-dimensional graph, but only one variable is going to be changing because x is always 4. So we learned on Friday that this is actually going to be a vertical line. Vertical line. Yeah, so it's a vertical line that passes through 4 on the x-axis, and every other point that has 4 as its x. And so this is just a vertical line, something like so. Travels forever in both of those directions. Vertical line. Another way you can think about that if you didn't have it memorized is just start plotting points that have 4 as their x coordinates, right? So here's 4, 0. So as you're putting your cell phone away, you would be plotting these points, right? Here's 4, 3. Here's 4, -5, right? And every point that has 4 as its x coordinate would line resulting in that line. All right? That's all they asked us to do there. Here we go. Find the x and y intercepts of the graph. So this was a little bit trickier. I'll do this in 2 separate colors. So the x intercept, the way we found that was plug in 0 for y. Kind of the opposite of what you might have suspected. So I'd have -6 times x plus 9 times 0 equals -18. 9 times 0, that's just 0. So -6x equals -18. Better yet, no, I liked your divide, but divide both sides by -6 to deal with a sign. Oh, did you? My apologies. My apologies, and no worries. X equals +3 because those minus signs cancel out as well. So this is my x-intercept. You also could think of that as the point 3, 0. To find the y-intercept, the y-intercept, one might say, plug in 0 for x. That makes sense. So -6 times 0 plus 9y equals -18. 6 times 0, -6 times 0. Anything times 0 is 0. So that's just 9y equals -18. What do I do now, Ben? How do I get rid of that 9? That's right, both sides. Yep. So y equals -2. So this corresponds to the point 0, -2. Notice that the 0 is in the x place. Over here, the 0 was in the y's place. And so that is the x and y intercepts. Now, they just wanted me to find them of the graph of the linear equation, although for this problem, you didn't actually have to graph it. Wow, that's nice of them. That's nice. Let's take a look at 15, though, where we will graph it. So once again, same approach. So x int, plug in 0 for y, -12x plus 3 times 0 equals 24. Right? It's just kind of almost pretending as though the y doesn't exist. Think about it. -12x. X is -2 is how you'd say that, right? No? By both sides by e was number 1. No. Yeah. You guys got it. Yeah, SpongeBob definitely. Actually, someone has created some artificial intelligence of SpongeBob that has then since become dictator of the world. For the y-intercept, I'm plugging in 0 here. 0 for x to find the y-intercept. 3y equals 24. Tell you what y equals 8 when I divide both sides by 3. So I plot these points. X equals -2 is right here. Y equals 8 is right there. And then I draw the line that connects the dots, right? And how many lines pass through 2 points? Only one. One line that would ever pass through 2 points. Yeah, but there are infinitely many points on that line. Yep, yep. So there we go. So that's how I graph it. Now, as a graphical explanation as to why I plug in 0 for y, check this out. If I wanted to find out where some old line crosses the x-axis, notice that every point on the x-axis has 0 as its y-coordinate. Here's -5, 0, here's 0, 0, here's 0, here's pi 0, here's 8, 0. That 0 is the y-coordinate of every point on the x-axis. So one of the reasons I plug in 0 for y is because it's like I'm trying to find the point where it crosses the x-axis, and I know 0 is going to be the y-coordinate. For similar reasons, you can find the the y-intercept by plugging in 0 for x, because notice every point on the y-axis has 0 as its x-coordinate. Here's 0, -5, 0, -10, 0, 3. And so by plugging in 0 for x, I'm finding the point where the line crosses the y-axis. Excellent, excellent. All right, 23. If you have a hard time on 24, I already have a video posted on that one from last year. Here's 23, though. Oh, football team has an away game, and the bus breaks down. Oh, no. The coaches decide to drive the players to the game in cars and vans. Question, comment. Maybe they rented some. Oh, could have been, yeah, could have broken down. Well, it was, yeah, well, they were all still at school, maybe. Yeah, if they were halfway there, they're living on a prayer. Yeah, there are interesting liabilities there as well. Good point, good point. But in this world, these coaches decide to drive the players to the game in cars and vans. 4 players can ride in each car, 6 players can ride in each van. There are 48 players on the team. The equation 4x, 4 times the number of cars, plus 6y, 6 players times the number of vans, is going to equal 48 situation. Where x, right, I said is the number of cars, y is the number of vans. So let's graph this equation. So fortunately, they gave us the equation. Eventually, we'll be writing some of our own equations based on problems like this. But for right now, they gave it to you. Does that kind of make sense, right? 4 people per car multiplied by the number of cars. This is the total number of people traveling in cars, right? 6 people per van times the number of vans is going to represent the total number of people riding in vans. And when I add the number of people in cars plus the number of people in vans, that's the total. Yeah, I think it makes sense. I don't think we need to do that. So let's graph using the X Intercept and Y Intercept method. This week I'll be showing you some other strategies for graphing. This way is faster than making a table of values, I find. So to find the X-intercept, I'll plug in 0 for y. Tell you what, I don't even need to write 6 times 0. I just know that it's going to disappear. And so I'll have 4x equals 48. Solve for x. I'll divide both sides by 4. And I will end up with x 12. Conveniently, that's right there. Fits on my graph. Find the intercept. I'm going to plug in 0 for x. So here I'd have 0 plus 6y equals 48. Divide both sides by 6. And I get y equals 8. So here is 0, 8. And so let's graph our possible outcomes. And technically, notice I've only got my graph highlighted significantly in the first quadrant. Why don't I have negative x values that I'm considering? X represents the number of cars, And it's kind of weird having negative cars. That's kind of weird. I don't understand. Like, we know that antimatter exists, but we haven't really found it yet. So yeah, we don't know how to make an antimatter car. And the same for Y. Notice I have no negative Y values here because I don't know what antimatter vans look like. I don't know. It's weird. Now, technically, I just drew a line segment between those points, but I also don't have all of the points that I showed there because I can't drive like 1/3 of a car or 7/10 of a van. That's hard to do. Really hard to do. So I think that my solutions are only going to be wherever it crosses the grid. Looks like there, and there. All right. As well as these. So possible solutions are like 0, 8, meaning I take no cars and all vans. It's a big day for vans. Or here is 12, 0. It's like, I'm afraid of vans. Cars all the way. 12 cars, no vans. Or some combination of each. So this is like 3, 6. 3 cars, 6 vans. Or 6, 4. 6 cars, 4 vans. Or let's say like 9, dos, which would be like 9 cars and 2 vans. Yeah? Yeah? So those are my possible solutions. They only needed you to find 4 in the context of the problem. Graphing the equation would have resulted in a line segment, but I restricted that to just the whole, like so. Yeah. Yep. Let's see. Sake of time, I think I'm done, son. All right. Take it easy, internet friends. All hail President SpongeBob.